Okay, for number 20. Now, for the word problems from number 20 through 24, they involve a few concepts, primarily arc length and sector. Now, when we talk about arc length and arc length and area of a sector, so the concept of an arc length is that it is just part of the circumference. So that's why we have an equation. We say the equation is arc length. If the angle is measured in degrees, it is theta in degrees over 360 degrees times 2 pi r. It's a very simple part over whole, that kind of concept. Okay, theta over 360 is equal, and then times 2 pi r. If it is in degree, theta in degrees. Okay. Now, what about if the theta is in radian? If the theta is in radians, then we have another equation. Now, before I talk about the formula, I wanted to make sure that you actually knew this indirectly. Okay. Not explicitly, but you actually knew it, because you learned about circumference is 2 pi r, right? You know about circumference being 2 pi r. Well, circumference is actually arc length, and the radius is right here. The 2 pi is the theta. So that's how we have S is equal to r theta, okay, r times theta. People like to say r theta instead of saying theta r, so that's why I reversed the order right here. Arc length is equal to radius times theta, and 2 pi, as we learned in class, is the radian measure of the full circle. So that's the equation. Okay, so if it says find the arc length when the radius is 12 inches and the central angle is 5 pi over 6, hey, we just basically plug in numbers. Okay, plug in numbers, right? Like this, r theta. That's it. And here's another thing. Please, please, please simplify before you multiply. Okay? Like, is there anything wrong if you multiply and then simplify? Well, that's nothing wrong officially. It's just not very wise. Why would you want to bring a number greater before you bring it down? It's a lot easier to just simplify it first so that you can handle some small numbers. So we say, oh, S is simply 10 pi inches. Okay, 10 pi inches. And the instruction sets that give exact and estimated answer. So this will be your exact answer because we're not rounding anything. 10 pi is the exact answer. And the approximated answer is where you would type in 10 times pi, and it would give you 31.4. 31.416, you round it up, 31.416 inches. Okay, that's the estimated, okay, answer. So that's it. Okay, you have to give both. Okay, you have to give both answers, both exact and estimated. So again, if it's exact answer, you just keep the pi in the answer. If it's estimated, you just give the rounded answer. Okay, so and then for the next one, question 21, we have the area of a sector. Now, a similar idea like the previous one. If it's area of a sector, part over whole. So if the theta is in degrees, it's theta over 360 degrees times pi r squared. You have the area of a circle, and then you just go ahead and, multiply by the part. Okay, what's the part? Theta over 360. So if theta is in degrees, this is what you will do. Okay, well, in this case, seems like a good way to use it. Now, if it's in radians, okay, what would you do if it's in radian? Now, you can choose to memorize the equation, or you can just derive the equation actually. So you can say, oh, well, theta over 2 pi, right? 360 is 2 pi times pi r squared. And then if you simplify it, you can actually cross out the pi. So that means area of a sector is the theta in radian times r squared all over 2. Okay. Now for me, I think it looks nicer if we write it this way: 1/2 r squared theta. Okay, that's the equation I like to use. If theta is in radian, 1/2 r squared theta. Okay, 1/2 r squared theta. Right, so for this one, it's 35 degrees. So we're going to use this one instead because it's in degrees. So 35 over 360 degrees, and then pi, and then r squared. So we can just put everything into the calculator. Okay, so we have 35 divided by 360. The degree will get canceled out, and then times pi times r squared is 11 squared. So that it's 121. So then you have the exact answer. This is the exact answer. 847 pi over 72. 847 pi over 72. Cannot reduce it any further. Okay. Or if you want to get the approximate, the estimated answer, do this. Control Enter. You get 36.957. 36.957. And that would be in the unit of centimeters square, because you square the centimeters right here. Okay, so centimeters square would be the unit of the area. So again, we have two equations. One is in degree, the other one is in radian. Make sure you know which one is which. I personally think that the one in degrees, it's basically a no-brainer, because you learned about part of a whole ever since middle school. Okay, so and of course you need to know the area of a circle. So once you put these two concepts together, it's really straightforward. Okay.